Hello, my name is Edward Leonard, and I'm a professor in the chemical engineering department. And come lately to the game, I've decided to offer a course that I've given before, but never in the form that it's going to be offered this fall. The course is called Biological Transport and Rate Phenomena, and it's designed to be a course which allows chemical and biomedical engineers, primarily, others with a little makeup work, to look at the models that have been built of biological systems based on ideas out of engineering. Things like considering arteries to be pipes and membranes inside the body to be like membranes and membrane separators, and a whole host of other analogies like that. Now, this is a tricky game. As the course description describes, there's a bunch of things that we'd like to cover, but this is a very small part of the total picture. And in fact, I am calling this a course with two faces, but because rather than continue to pretend that the models that we write and deal with actually make large predictions about biological system behavior, we need to be more modest. We need to know that the entire process involves a kind of two-faced thing, which is shown in this second slide. Now, what we mean by this is just that the course can talk about these simple things, but they ought to be framed in their complexity where they come from, and their simplifications ought to be appreciated for what is emphasized, but also for what is lost. Now, the two faces that we're talking about here can be thought of as a left face and a right face. The left face is described on the next to last slide here, and it simply talks about the fact that what the course is doing is taking a piece of the whole and looking at it carefully and simply in terms of biomolecules and their movement and their reaction and their behavior in a kind of isolated environment where a lot of other things are not going on around them. This is not a useless simplification. It's a simplification that allows us to have a model in the back of our heads when we look at complexity, but it ain't the truth. Now, the right face is the whole issue of what is going on with these elements in function, how to map back into the biological system the simplifications and the reductions that we have made in order to get mathematical solutions. And it's a situation where we ought to be the better off for doing it, but we shouldn't be pretending that we have accomplished a wonderful simplification so that we could go out and build an animal or the like. In fact, we're working in a dark, dark forest with a little shiny light leading us through a part of it while we ignore the rest of it and hope for the best. Anyway, the course is going to run with lectures that are on the one hand dealing with the simplifications and supplemental lectures from time to time to remind you of where these systems are realized in a living system and what else might be going on around them. I hope you'll take the course. I hope you'll enjoy it. I hope you won't be sorry when you've ended. Thank you.